Welcome back to the IT Fundamentals Masterclass from Hired in IT. In Part 1, you learned the 7 core areas we will use to understand modern IT: hardware, operating systems, software, networking, security, cloud computing, and modern IT operations. Today, you will see how those areas work together inside a real business. Because when technology works, employees can sell products, communicate with customers, process payments, and make decisions. When it fails, business can slow down or stop completely. 8:07 a.m. The line is 14 people deep. The espresso machine is hissing, milk is steaming, and then silence. Every register screen goes dark. Nobody can order. Nobody can pay. The owner scribbles cash only on a napkin, but half the customers already walked. That half hour likely cost the shop hundreds of dollars in lost sales. This isn't a technology story. It's a business survival story. By the end of this video, you will be able to do 3 things. First, identify the major business activities that depend on computers, including sales, accounting, communication, operations, and customer service. Second, recognize the combination of hardware, software, networks, cloud services, data, and security controls that support those activities. Third, understand the kinds of problems IT teams are responsible for preventing, investigating, and resolving. The goal is not to memorize a list of products. The goal is to understand how technology supports the business and what happens when one part of the system fails. When you hear the words business computer, you may picture a desktop sitting on an employee's desk. But business computing includes much more than that. It includes laptops, tablets, smartphones, point-of-sale terminals, printers, barcode scanners, servers, network equipment, cloud services, and specialized devices. Each device or service performs part of a larger business process. A point-of-sale terminal records a transaction. A network carries the information. A payment service authorizes the purchase. An application updates inventory. A database stores the result. If one non-critical device fails, the business may continue with little disruption. But when a critical system fails, an entire process, such as taking payments or accessing customer records, may slow down or stop. Let's look at invoicing. A manual process might require someone to create a document, enter customer information, calculate totals, print or attach the invoice, send it, and record that it was delivered. That takes time, and every repeated step creates an opportunity for a mistake. Accounting software can make the process faster and more consistent. The user selects the customer, enters the products or services, reviews the totals, and sends the invoice electronically. The software may calculate taxes, reuse approved customer information, track payment status, and create an audit trail. Computers do not eliminate every mistake. A person can still enter the wrong customer, amount, or date. But a well-designed system can reduce repetitive errors, enforce consistent steps, and make problems easier to detect. Computers also help teams coordinate work. Tools such as Trello, Asana, Jira, and Monday.com allow teams to organize tasks in one shared location. A task can include an owner, due date, priority, status, instructions, comments, and attached files. Automatic reminders and notifications can make unfinished work easier to see. However, the tool cannot manage the project by itself. Someone still has to create accurate tasks, assign the right people, update progress, and respond when work is delayed. The technology improves visibility and consistency. The people using it still provide judgment, communication, and accountability. Let's pause for a quick checkpoint. A business replaces a manual invoice process with accounting software. Which benefit is the most realistic? A. The software guarantees that every invoice is correct. B. The software can reduce repetitive work and make the process more consistent. C. The software removes the need for employees. The best answer is B. Automation can save time and reduce some errors, but people still need to review the information and handle exceptions. Here is where computers help business leaders make faster decisions. Imagine a sales manager opening a Power BI dashboard. She selects a region and notices that September revenue is lower than August revenue. The dashboard does not automatically explain why the decline happened. It could be caused by seasonality, missing data, a product shortage, lower demand, pricing, or many other factors. But the dashboard helps her notice the pattern earlier. She can investigate the details, compare other metrics, speak with the sales team, and decide whether action is needed. A dashboard does not replace business judgment. It organizes data so people can ask better questions and respond sooner. Quick checkpoint. A dashboard shows that sales dropped by 20%. Should the manager immediately lower prices? Not necessarily. First, the manager should confirm that the data is complete and accurate, investigate the cause of the decline, and review other relevant information. Computers can process and display data quickly. People still need to interpret what the data means. Computers can help identify unusual activity, but they do not automatically understand every mistake. Imagine an employee entering $1,000 instead of $10,000. Both values are technically valid numbers, so basic accounting software may accept either one. The system can only flag the difference if the organization has configured controls, such as expected ranges, approval thresholds, matching rules, or anomaly detection. That is an important lesson in IT. A computer follows the data and rules it has been given. If the data is wrong or the controls are missing, the system may process the mistake perfectly. Many accounting systems are built around double-entry bookkeeping. Every transaction creates equal entries in at least two accounts. For example, when a company receives $5 in cash from a sale, the cash account increases and the revenue account also increases. Accounting software can check that the debit and credit entries remain mathematically balanced. However, a balanced transaction can still be incorrect. It could contain the wrong amount, customer, date, account, or description. That is why businesses also use approvals, reconciliations, audit logs, access controls, and human review. The computer helps enforce the accounting structure. People remain responsible for confirming that the transaction reflects what actually happened. A salesperson sends a proposal from an airport. A support team answers customer chats. Human resources interviews a candidate through video conferencing. Managers review daily reports from different locations. These activities depend on a combination of devices, applications, user accounts, networks, internet access, and cloud services. If email, identity, or network services become unavailable, employees may lose access to several tools at once. That is why IT teams monitor communication systems, manage user access, troubleshoot connectivity, protect accounts, and plan for outages. The technology connects the organization. IT helps keep that connection available and secure. Scheduling a meeting once required repeated phone calls, written messages, or long email conversations. Shared calendars make the process much easier. An organizer can view availability, select a time, invite attendees, reserve a room, and include a video meeting link. The system reduces much of the repetitive coordination. It does not remove every scheduling problem. People may still work in different time zones, have conflicting priorities, or keep inaccurate calendars. The computer reduces the administrative effort while people still make the final decision. A user can sign into a laptop but cannot open email, join a video meeting, or access shared files. Does that automatically mean the laptop is broken? No. Several different layers could be involved, including the network connection, internet access, identity service, cloud provider, application, or user permissions. IT professionals separate the problem into layers instead of assuming the first visible device is the cause. Email marketing platforms can automate repeated communication. For example, when someone voluntarily subscribes to a mailing list, the system can send a welcome message and schedule a series of follow-up emails. The platform may also track deliveries, opens, clicks, unsubscribes, and campaign performance. But the computer does not create a successful marketing strategy by itself. People still need to write useful content, obtain proper consent, protect customer data, follow communication laws, review results, and adjust the campaign. Automation handles the repeated delivery steps. Human judgment determines what should be sent and why. Social media management tools such as Hootsuite, Buffer, and Later allow organizations to plan and schedule posts from one dashboard. That can reduce the time spent opening several platforms and posting the same content repeatedly. The tools also provide analytics that can help teams compare engagement across posts. However, scheduled content still requires oversight. A post that seemed appropriate when it was created may need to be paused or changed when circumstances change. Automation helps the team publish consistently. It does not remove the need for review, judgment, or responsibility. Business data can help organizations manage inventory, staffing, sales, and customer demand. A dashboard may reveal which products are selling quickly, which items remain unsold, or which locations are experiencing unusual activity. Forecasting tools can estimate future demand by analyzing historical patterns and other available information. These systems do not guarantee higher revenue, and predictions are never perfect. Their value comes from helping decision-makers notice patterns, test assumptions, and evaluate possible actions. A useful dashboard depends on accurate data, well-designed metrics, and people who understand the business. Here is a question that connects marketing automation and analytics. What should a business do when a dashboard shows that one campaign produced more clicks than another? The business should investigate further. More clicks may be positive, but the team should also review conversions, cost, revenue, audience quality, and whether the data is accurate. One number rarely tells the entire story. The right computer depends on the employee's workload. A person using email, documents, spreadsheets, web applications, and video meetings generally needs a modern processor, enough memory for multitasking, and a solid-state drive. For many current office workloads, 16 gigabytes of memory provides a comfortable starting point. Lighter workloads may use less, while video editing, engineering, software development, data analysis, or local virtualization may require much more. Avoid choosing a computer based on one specification alone. Processor generation, memory, storage speed, security features, battery life, warranty, and manageability all affect the final decision. The goal is to match the device to the work it must perform. Different types of computing resources solve different business needs. A laptop supports employees who travel, work remotely, or move between meeting rooms. A desktop can provide a larger workspace, easier repairs, and better performance for employees who remain in one location. A server provides shared services that many users or applications depend on. That server may be physical equipment in a company facility or a virtual machine running in a cloud data center. The correct choice depends on mobility, performance, security, support requirements, and cost. Buying the least expensive option may save money initially, but create lost productivity later if the system cannot support the employee's work. Businesses commonly use Windows, Mac OS, and Linux, often within the same organization. Windows is widely used because it supports a broad range of business applications and can be centrally managed by IT teams. Mac OS is used in creative, executive, development, education, and other environments, especially where organizations prefer Apple hardware and software integration. Linux is widely used on web servers, cloud platforms, network appliances, developer systems, and many specialized devices. Windows Server is also common in enterprise environments. The best operating system depends on software compatibility, security requirements, management tools, employee needs, vendor support, and organizational standards. Cloud computing allows organizations to use software, platforms, servers, storage, and other resources without owning all the underlying physical equipment. Software as a service, or SaaS, provides a complete application such as Microsoft 365 or QuickBooks Online. The provider manages the application and underlying platform, while the customer still manages users, access, configuration, data, and many security decisions. Platform as a Service, or PaaS, gives developers a managed environment for building and running applications without managing every part of the operating system. Infrastructure as a Service, or IaaS, provides virtual servers, storage, and networking that the customer configures and manages. The provider and customer share responsibility. Moving to the cloud does not automatically make a system secure. It changes which responsibilities belong to the provider and which remain with the business. Why might a small business choose a cloud accounting service instead of installing accounting software on one office computer? A SaaS product can make the application easier to access from different locations and may allow the provider to handle much of the application maintenance, infrastructure, and software updates. However, the business still needs to manage user accounts, permissions, configuration, data protection, and recovery requirements. SaaS reduces some IT responsibilities. It does not eliminate all of them. Security is not one product or one setting. It is a collection of layers that work together. Businesses should protect accounts with strong authentication and multi-factor authentication. They should keep operating systems and applications updated. They need endpoint protection, firewalls, secure backups, least privilege access, employee awareness, monitoring, and a tested incident response plan. No single control can stop every attack. The goal is to reduce the chance of compromise, limit the damage when something goes wrong, and recover safely. Imagine a small architecture firm discovering that ransomware has encrypted project files, contracts, and invoices. The first step is not simply to restore everything immediately. The organization must isolate affected systems, determine the scope of the incident, protect evidence, reset compromised access, and confirm that the attacker no longer has control. Tested backups can make recovery much more achievable. A common strategy is the 3-2-1 rule. Keep 3 copies of important data, store them on 2 different types of media or systems, and keep at least 1 copy off-site. For stronger protection, at least 1 backup should also be isolated, offline, or immutable, so ransomware cannot easily change or encrypt it. Backups do not prevent an attack. They provide a safer path toward recovery. Let's try one basic troubleshooting command. Open command prompt, PowerShell, or terminal and type ping google.com. If you receive replies, your computer successfully resolved the name and reached a destination that responded to the ping request. That is a useful sign, but it does not prove that every website, application, or network service is working. If you receive no reply, it also does not automatically prove that your internet connection is down. A firewall or destination system may block ping traffic. The command is one test, not a complete diagnosis. The important habit is to collect evidence, test one layer at a time, and avoid jumping to conclusions. Let's bring the lesson together. Businesses depend on computers to process sales, manage finances, communicate, organize work, analyze data, protect information, and serve customers. But no business activity depends on only one device. A complete system may include hardware, operating systems, applications, networks, cloud services, user identities, data, security controls, and people. Computers improve speed, consistency, communication, and scale. They do not eliminate mistakes, replace judgment, or guarantee that a process will succeed. That is why IT teams monitor systems, manage access, maintain devices, investigate failures, protect data, and restore services when something goes wrong. In the next video, we will explore enterprise IT infrastructure, the behind-the-scenes systems that connect employees, applications, servers, networks, and cloud services across an organization. Before you leave, complete one practical assignment. Choose a business you understand, such as a coffee shop, clinic, school, retail store, restaurant, construction company, or small office. Create a document or spreadsheet with 3 columns. Label the first column, business activity. Label the second, technology used. Label the third, what happens if it fails. Add at least 5 activities. You might include taking payments, communicating with customers, scheduling employees, storing documents, managing inventory, or processing invoices. For each activity, identify the hardware, software, network, cloud service, data, or security controls it depends on. Then describe what the business would experience if that technology became unavailable. Save the file inside your IT Fundamentals study folder. You have now created a business dependency map, the same type of thinking IT professionals use when planning systems, evaluating risk, and troubleshooting outages. Careers are built by practicing, documenting, and learning how technology supports real business needs. Thanks for watching Hired in IT, where we turn IT knowledge into career opportunities.